In lesson 15.2, we're going to use the addition rule again, but in this lesson, we'll be looking at using Venn diagrams to organize some information. All right, suppose that we know 80% of students at West Ottawa High School use Instagram, 60% use Snapchat, and 45% use both. We're going to organize this information into a two-way table. Now, one thing you might notice right away is that if you add those percentages together, 80, 60, and 45, you get more than 100%. However, we know that the total for the table should be exactly 100%. So let's look at why those probabilities make more than 100%. The 80% of students in West Ottawa High School that use Instagram represents the total percent that use Instagram. So that 80% would actually go at the bottom of the Instagram column. The 60% that use Snapchat is the total number or percent of students that use Snapchat, which would go at the total at the end of this row. And then we have 45% of students that use both. The part of the table where students use both is in the upper left-hand corner, where they're in the Snapchat row and the Instagram column. So because we have a large number of students that use both, and they're being counted as part of the 60% and part of the 80%, 60 plus 80 gives us more than 100% total. Now, based on what we have here, we can fill in the rest of the table. For example, if we know that 60% use Snapchat, that means 40% don't, and 60 plus 40 give us 100 altogether. If 80% use Instagram, that means 20% don't, and 80 plus 20 make 100%. Now we can fill in the rest of the boxes in the table. For instance, here I got 15% because I know that that top row has to total 60, and 60 minus 45 gives me 15. I can do the same thing with this column. 80 minus 45 leaves 35% of students that don't use Snapchat but use Instagram. And then that final box, of course, would be 5% because 35 plus 5 would give us 40% for the row. 15 plus 5 would give us 20% for the column. Now, in this case, if we take these four percentages and we add them together, those will total 100%, and that's what we need. Now, we can take these four percentages and we can put them into a Venn diagram. And the Venn diagram looks like this. Notice one of the circles is labeled with S for Snapchat. The other one is labeled I for Instagram. And there are four regions in the Venn diagram where we're going to fill in the four numbers from our two-way table. First, we're going to start in the middle. The 45% where the students use both Snapchat and Instagram will go in the center in that football-shaped overlapping region. Then we have 15% of students that use Snapchat but not Instagram. So that will go there. Then we have 35% of students that use Instagram but not Snapchat. And finally, we have 5% of the students that use neither. So those 4% altogether total 100%. Now, in part C, it asks us, what is the probability that a student will have Instagram or Snapchat? Here, we are looking at anything inside the circle. So when you see or here, that refers to students that use just Instagram, which is 35% here. Students that just use Snapchat, which is 15%, but it also includes this middle region right here, the 45%. So if we add those all together, that gives us 95%. And for part D, the probability that a student will have neither, that's the 5% on the outside. So if you're looking for the probability of or when you're working with Venn diagrams, it's anything that is inside the circles, including the overlapping part. Neither is outside the circle. Let's look at example 2 where we have a Venn diagram already given. Here we have a group of student athletes that were surveyed about which sport they're going to play this year. And F represents student playing football, B represents students playing basketball. Notice that all four of those regions are already labeled, and the four percentages should total 100%. Letter A says, what's the probability that a chosen student plays football and basketball? When you see and you're working with Venn diagrams, and means they play both, and that's the overlapping region in the middle. So that would, of course, be the 22%. Letter B says, what's the probability that the student plays football but not basketball? Here we're looking for kind of the Pac-Man shaped region on the left-hand side where the student is inside the football circle but not inside the basketball circle. So everything that's in that circle but not in the overlapping part, which is the 33%. The probability that a chosen student plays neither sport would, of course, be the 28% that's on the outside of our circles. And then part D says, what's the probability that a chosen student plays basketball? Here you have to be a little bit careful because it doesn't say, but not football. So playing basketball means it could be anybody inside this entire circle. So students that just play basketball and students that play basketball and football. So we need to add the 22 plus the 17 together, which gives us a total of 39%. Now we're going to put this information into a two-way table. And the four numbers from your Venn diagram go into the four central boxes in your table. So in the upper left-hand corner, we have students that play both, play basketball and play football, which is the 22%. Next, we can fill in the ones that play basketball but not football. So that's inside the basketball circle, but not in the overlapping part. That's the 17%. Playing football but not basketball is the 33%. And then the ones that play neither sport are the ones on the outside, which is the 28%. And from there, we can go ahead and total up the rows and the columns. So we have 55% and 45%. Notice those make 100 if we add them together. If we add the rows, we get 39 and 61, which all together give us 100%. Here's another example where we're going to use some information to fill in a Venn diagram. We know that the probability that basketball wins the conference championship this year is 0.65, and that's what the C represents in that Venn diagram. The probability they beat their rivals is 0.72, that's the R circle, and the probability that they do both is 0.4. Notice again, if we look at these three probabilities that are given, we have 0.65, 0.4, 0.72. So we already have three probabilities that altogether total more than 100%. And the reason that's happening is because we have some overlap. So we're going to fill in those numbers into the Venn diagram. Actually, we're not going to use all of those numbers in the diagram, but we're going to use them to figure out the numbers in our Venn diagram. I would recommend that you start with the center region always. So the center region represents both of those events happening, which of course is the 0.4. So we'll put that in there. Now, if we want to fill in the rest of circle C, we can't just fill in 0.65 right here, right? Already 0.65 and 0.4 is more than 100%, so that can't be correct. And the reason that doesn't work is because we want the entire circle to total 65%. So if we want it to total 0.65 and we already have 0.4 in there, we want to subtract. So 0.65 minus 0.4 leaves us with 0.25 in the rest of that circle. And now that entire area that's shaded in green totals 0.65. Now we can do the other thing for the R circle. The probability they beat their crosstown rivals is 0.72. So that means we want this entire circle to total 0.72. And I already have 0.4 in there. So 0.72 minus 0.4 leaves us with 0.32 in that outside part of that circle. Now those three decimals, if I add them together, do not total 100%, but they're close. So to figure out the part that would go on the outside of those circles, we would add those three probabilities and subtract from 1. And that leaves us with 0.03 on the outside of that circle. So now the four regions are filled in. Part B asks, what is the probability they beat their crosstown rivals but do not win the conference championship? That would mean in circle R, but not in circle C, and that would be the 0.32. Part C is asking us for or, the probability they beat their crosstown rivals or win the conference championship. And again, remember, anything with or means the total of everything inside the circle. So 0.25 plus 0.4 plus 0.32. In example number 4, on this one we don't have a Venn diagram to use, and actually this one is easier if you use the addition rule and not use a Venn diagram. Here it says the probability that a swimmer gets a best time in the next race is 0.49. The probability that she wins the next race is 0.62. If the probability she gets a best time or wins her race is 0.84, what's the probability she'll do both? In this one, it's difficult to use a Venn diagram because we don't know the both part, which is the overlapping region. And so that makes it difficult to fill in the rest. So instead, we're going to use the addition rule. And the addition rule formula in this case would say the probability of B or W, now in this case, B means best time and W means win, would be the probability she gets a best time plus the probability she wins minus the probability that she does both. And that would be the overlapping part in her Venn diagram that we don't know. So I have 4 spots in that formula for numbers. I know 3 of the 4, which means I can fill those in and solve for the one that I don't know. The probability that she gets a best time or wins the race is 0.84. The probability she gets a best time is 0.49. And the probability she wins is 0.62. The overlapping part, the and, is missing, so I'll put minus x. And we'll just use a little bit of algebra to solve that, and we get x is 0.27. So keep in mind with many of these problems, you can use a Venn diagram or the formula. Sometimes there's an easier way, but it's really kind of up to you how you want to approach these problems. Please do the assignment for section 15.2 in your homework packet.